So here's a quick video to look at each of the steps of the analysis. To start with, we're going to look at one that helps you get to your value for G. So we start with the equation here. And we've already gone through this stage, but it's worthwhile just recapping it. So multiplying this out essentially gives us this. Now I've just rewritten those two terms the other way around because it's going to match a little bit better when I want to put this in the form y equals mx plus c. I know that L is a constant, so that's going to become my y-intercept, but I don't really care about that. I'm not going to use it. I could get that to find G, but I'm not going to go down that path because it's a bit of an extrapolation. It's not a very accurate way of doing it. What's a better way is to identify my x and y axes. So if I put t, remember this is the time for one period. Okay, if you're dealing with times where you've recorded 10, you need to divide those times by 10 to get t for one period. If you just use the time straight out, this is going to go wrong. The x-axis, handily enough, needs to be root x. And again, this is the root of the x value, but it must be in meters first. So you've got to convert that to centimetre. If you're doing it in centimetres, convert it to meters before you do the root. And equally, the period must be in seconds. That's going to give you a graph and a gradient, and the gradient will be that term there. So the gradient is pi over root g. So in order to get g, you take the gradient of the graph of t against root x, rearrange this for g, gives us pi squared over m squared, where m is the gradient. So it's dead easy to get your value for G. You've just got to get your x's into meters, square root them, get your time period for one oscillation. Okay, so if you've got multiple readings for 10 oscillations, find the mean of those, but then you've got to divide that mean by 10. The time period is for one oscillations, and it must be in seconds. Plot t against root x, take the gradient, and quite simply do that calculation with the gradient, and that gets you your value for G. Couldn't actually be more straightforward. Just make sure you pay attention to the graph, that the axis is as large as it can be. Remember, we don't care about the y-intercept. So if your plotted points don't, for example, start until sort of there, then this part is dead space. So you don't have to start at 0, 0. You should be starting perhaps around about there and making your graph, essentially your graph paper should be that part of the graph. So do make sure you follow all the rules for graphs, give it a title. And the other thing, of course, you've got to think about is the uncertainties, but we'll look at that in the next video.